Good morning. This lesson is for my Trig-Precalc class. This is Chapter 1, Lesson 4. Before I get started, I want to say I hope that everyone is doing okay out there. So this lesson, when we start it, it's going to seem like it's not related to what we've been working on, but it is in fact related to what we've been working on. So again, I'm trying to weave a story about this math in such a way that there's commonalities with each lesson, and the story is easier to follow. And I'm going to continue the story right now of plugging in goofy numbers by reviewing inverses and verifying inverses. And then I'm going to discuss for a little bit what that implies. I think this is going to be a pretty simple lesson for you. I also want to point out that for the notes portion of your grade, I'm going to start to require that I must see the goals written on your notes. If I don't see the goals written on your notes, you're going to get a 4 out of 5. I want to see the goals on your notes, because when you go back to look at your notes, you want to know what the notes were telling you instead of just seeing problems worked out. If you go back to look at it for help and there's no description of what these notes are about, it might as well be written in a foreign language. So, as I've been grading some of your notes, I've seen wonderful notes, and I've seen some kind of like, I just write something and then. But these notes are for your benefit, so the better off you write these notes, the better off you're going to be. But I am requiring that I see the goals written in your notes. That's a new requirement. I'm sorry if that causes any extra work, but again, if I'm going to be a good teacher, I'm going to have to expect you guys to do good things. So let's go ahead and just jump right in. I'm going to talk about finding inverses of functions, and it's actually pretty easy to do. We're only going to work with linear today, which means that there's no exponents, and so it's going to be kind of easier to see what's going on here. All right. So our first goal is to find the inverses of functions. And so what I did was I wrote down what are steps that we need to do to find the inverses. And the very first thing we're going to do is we're going to switch the x and the y, and then we solve for y, and then we replace the y with the f. This says f inverse of x, and I'll write that down. So this tells us that we have an inverse, right? This, as a sentence, this would be f inverse of x. That's how we would describe that symbol. And that tells me that we have the inverse, or the opposite, in a sense, of our original function. So here I have a nice simple linear function, which would be actually pretty easy to graph. And so I'm just going to go through the steps. So step 1 says switch x and y. And by the way, we are building a cheat sheet in this class. And it's a blank piece of paper and I'll tell you to add things, because again, I want you to have quick access to concepts. This would be a really good thing to put on your cheat sheet. Even this, I would just write, title it steps to find inverses. And I would put this on a piece of computer paper or a nice piece of line paper that you could easily find. In years past, I've actually had students write their cheat sheets on nice colored paper, and so that way when they're in their notebooks, it's a piece of paper that stands out, and you can see that we're going to fill all this stuff in. And it's helpful to have the steps written down for you in a nice organized location where to use. So let me, again, I would write this on my cheat sheet. But anyways, let's go ahead and use the steps here. So my first step is going to be to switch the x and the y. So this y moves to where that x was, this x moves to where that y was. So now we're going to get this. X equals 3y plus 7. So I did step 1. I switched my x and my y. Now I need to solve for y. I need to get y by itself. I need to get this guy by itself. And so I'm going to accomplish that by subtracting 7. And then these 7s are going to cancel, but I don't know what x minus 7 is, so I'm just going to leave that as x minus 7, and that's equal to 3y. I need to get the 3 away from the y, and I do that by dividing everyone by 3. So I'll divide the right side by 3, and I'll divide the left side by 3, and I'm left with x minus 7 over 3 is equal to y. All right, so I solved for y. I did my second step. And by the way, this equation is correct if you would have divided each of these individually by 3, x over 3 minus 7 over 3. But I want to show you that just put a fraction under the entire side of the equation. It's going to make it easier when we actually verify functions or inverses. All right, so we did step 2. We solved for y. We got x minus 7 divided by 3 is equal to y. But I want you to actually replace y with f inverse of x. That little -1 means inverse. Okay, so I now have x minus 3. I'm sorry, x minus 7. I can do this. X minus 7 divided by 3 is equal to f inverse of x. Okay, that's my inverse function to this, hopefully. And again, I don't have to say y. I can say f of x. So we found an inverse, hopefully, of our function. So I'm going to check off goal number 1. Goal number 2 is about verifying functions are inverses. And I have written on the board something that probably makes no sense at all. It looks like gibberish. And to be honest, if you see this, it doesn't make much sense. But remember, the notation that we use is actually very beneficial in the fact that if you understand what it means, it's actually easy to unwind and understand. So what I'm saying here on the first one, what this is saying right here is that I'm going to plug my inverse into my original, and it should just equal x. So remember, we've been plugging in goofy looking numbers, and this is a goofy looking number that I'm going to plug into x, and you're going to see why here in a second. I want it as one fraction as opposed to 2. But that's what this is saying. Plug the inverse into the original. Now the second one is saying plug the original into the inverse, and it should be x. This is called composition. Composition is when you plug one function into the other. And that's one of the things I wanted to do with these lessons about finding nice ordered pairs, right? Because I wanted you to get used to plugging in goofy looking numbers. But these goofy looking numbers that we plug in aren't going to create a nice number in return. What they're going to do is they're going to create x by itself. And that's how we know we have an inverse. So let's do the inverse into the original. Okay, so we're going to take the original and we're going to plug the inverse in. Okay, so if we just kind of ignore this and write this out, you see that, actually, let me go back one step. Where's my eraser machine? There you are, eraser machine. You're all the way over here. Let me go back a step. We're talking about our original function. Don't worry about this. So if I have my f of x, but I'm not going to write x, I'm just going to leave it blank, and I'm going to leave this blank. Okay, so I'm telling you to plug in your inverse function. So on the left side, I'll plug in the notation for the inverse function. And then on the right side, I'll actually plug in the inverse function. All right, so let's go ahead and simplify this. Here's why this is nice, and I wanted you to leave it as one fraction. These guys cancel. And now I'm left with x minus 7 plus 7. Those guys cancel, and so I'm just now left with x. That's exactly what I wanted. That's exactly what I wanted. I want to make sure I'm in the whole picture here. I had a feeling that I'm not, and I'm not. Let's see if I can move this camera so that... Okay, so now you can see what composition is. All right. So this one works. All right, so now let's write the inverse without the x's. Okay, let's write the inverse without the x's. So the inverse without the x's is going to look like this. And I'm sorry about this. I'm really sorry about this. This is going to be a little hard to see, and I'm going to try my best to stay on the page. All right. So now I'm going to plug in my original. So f of x goes in on one side, 3x plus 7 goes in on the other side. So I'm plugging in my f of x notation on my left, and then the 3x plus 7 on my right. So we can actually remove these parentheses now that we plugged in, and what's nice is the 7s are going to cancel. And now I'm just left with 3x over 3. The 3's cancel, and I'm left with my x. So this verifies for me that, in fact, I do have an inverse here, right? These functions right here are opposites of each other. So I'm actually going to stop this video here. I'm going to make an entire video just about this. I think that would it would be best to break it up, but I think it would be good just to see this one video of finding the inverse of functions and verifying that inverses are verifying functions are in fact inverses. So again, I would put this on our cheat sheet, and you could put this on our cheat sheet, and I would title this "Verifying Inverses." And you could define composition as well on your cheat sheet. So again, I hope everyone's doing okay out there. I will work on this. We'll just create a separate lesson for this, but it is worth a talk about that. So I will talk to you later. Have a good day, everyone. Bye-bye.